Hello, today we're going to be working on factoring higher degree polynomials. When I say higher degree polynomials, I mean polynomials that have a highest exponent of 3 or more. So we're going to start by multiplying out one of these polynomials. So this is a third degree polynomial. The reason it's third degree is because if I multiply this whole thing out, which we're going to do in a moment, I would see that I have an x times an x times an x, which is x to the third. So x to the third, that would be my 2x to the third is going to be my leading exponent. But as previously discussed in earlier videos, that right there tells me that that is a third degree polynomial. So we're going to multiply this out. If you're already comfortable with this part, I would go ahead and skip right through it, but I didn't make a video for 6-4, so I wanted to put that on here. So each of these is a factor. All those three multiply together to give me my overall polynomial, but this is a polynomial. Anyway, so when we're using the area model, these boxes, by the way, are the area models. We put the factors on the outside, and the inside is what we put together to make our standard form polynomial. So I'm going to take the 2x plus 1 and the x minus 4. I'm going to multiply those two out first. When I do this, I take the x times the x. It's those two parts, basically the length and the width of each that multiply together. That's why it's referred to as an area model. So 2x times x gives me 2x squared. X times 1 gives me 1x. Negative 4 times 2x is going to give me negative 8x. And finally, negative 4 times 1 is going to give me negative 4. So when I look at this, 2x squared can't be combined with anything else inside of this area model. The only two things that I can combine are my 1x and my negative 8x. So I'm going to combine those two to get negative 7x. So my resulting polynomial for that part is 2x squared minus 7x minus 4. So I'm going to take that part, let me erase this because I need the space. I'm going to take that part and put it on the outside of the 2x3 polynomial, or 2x3 area model. And then I'm going to take that x plus 6 from up here, and I'm going to multiply that out. So 2x squared times x. If I have an x squared and x to the first, I'm multiplying x by itself 3 times total. So this is going to be 2x to the third. 2x squared times 6, 12x squared, negative 7x times x, negative 7x squared, negative 7x times 6, it's negative 42x, negative 4 times x, negative 4x, and negative 4 times 6, negative 24. So then I want to look at what my like terms are. And in this case, I have like terms of 12x squared and negative 7x squared. I also have negative 42x and negative 4x. So when we are, and this caused some confusion, when we're multiplying things together, so we're multiplying all the factors from the outside, we're multiplying each of those parts, we can multiply unlike terms because an x squared times an x is giving us that x to the third. But when we add them, which is what we're doing to all this stuff inside, we can only combine the things that are like terms. X squared, x, x. Plain old number, constant, can't be combined with anything, and x to the third. I don't have any other x to the thirds to combine to that. So, whoops, that's not the color I wanted to be in. So my resulting polynomial in standard form is going to be 2x to the third 12x squared minus 7x squared, or plus a negative 7x squared, is going to give me 5x squared. Negative 42x plus a negative 4x, or minus 4x, is going to be negative 46x. And then minus 24. So that is my standard form equation. And so these two, those are equivalent. They're the same equation, written in a different form. So that was kind of what we covered in 6.4. What we're going to be doing today in this video is going from the standard form back to the factored form. So we start with we need a root for this. So there's a couple different ways that we can get that root. First of all, we have this polynomial. One of my colleagues and I were talking about it the other day, and the way we used to do it had to do with, oh gosh, some property I cannot recall now, but ended up narrowing it down and then doing guess and check. But what we have is the luxury of graphing calculators. We can plop this into the calculator and it'll give us our little graph, and we can see where it's actually crossing the x-axis. This particular one is crossing the x-axis at negative 2, 0. And that means that we have a factor of x plus 2. And it's important that you're recognizing the difference between the factor, which is part of the equation, and the root, which is part of the graph. If we have the root, remember the root is the number that makes this factor equal to 0, because at the x-axis of a graph, y always equals 0. So that's what we're going for. So the first thing that we're going to do, we're going to start by putting that factor on the side at the beginning, so we'll write this as steps. And then we want to put the first term in this box right here. And I'm going to, hang on just a second. I always put it in the lower left box because I put my x right here. But some people put the x up here, so it would be x plus 2, and then they do across the top. There's a lot of different ways to do it, but this is just how I'm doing it. And then we have this process that we're going to repeat until we get the box finished. And that process is factor, multiply, solve, or subtract. And we'll talk about that when we get to it. So we just put in our first term. Now we need to factor. So I'm going to take something multiplied by x gives me x to the third. So I need x to the second, x squared, to multiply to give me x to the third. Then my next step, so that was factor. My next step is to multiply. I can multiply the x squared times the 2, because those are the two things I have on the outside. It's going to give me 2x squared. Now is this solve subtract step, this one right here. So I know that in my equation I have 12x squared. And I know that my x squared terms have to add up to be 12x squared. So the reason that I'm saying this is solve or subtract for this step, you can subtract 12x squared minus 2x squared, and you get 10x squared. Some people struggle with that when it comes down to negatives, so I'm going to show you what I mean by the solve part. So I'm just going to shrink this down. No, let's not do that. Okay. I'm going to scooch that over really quick. So I know that 2x squared plus something in that box is going to equal 12x squared. This particular method, solving instead of just subtracting, tends to work better for people when there are more negatives involved. So you may want to keep this one in mind. Subtract 2x squared from both sides, just like you would solve a regular equation. So that box needs to be 10x squared. So go back to this. There we go. So that's going to be 10x squared. So those were the 3 steps. Factor, take out that x squared, multiply, and then subtract to get that missing box. And then I just repeat. Ew. Actually, let's write it on the side here. Just repeat that process until you're finished. So I'm going to factor x times something gives me 10x squared, so that's going to be 10x. Multiply 10x times 2, you get 20x. Then I have 44x for my x term, minus the 20x is going to give me 24x. So just to clarify that point, 44x, these two are going to add up to 44x, so 44x minus 20x gives me 24x. I'm going to factor out 24 and multiply again to get 48, 24 times 2. And if this is a root, 48, these two should always match if it is a root. And we'll talk about next section what to do with this. So I have a partially factored form here. My first factor is that x plus 2 from the side. And then my other factor is a quadratic x squared plus 10x plus 24. Some people are still struggling to solve factor quadratics, but once you're done there, you need to factor this part. And you can do that several different ways, box and diamond, whatever. I'll show you a version of that. Lower left corner, x squared, opposite corner, 24. So first and last terms of that quadratic. These two multiplied together give me 24x squared. And I need 2 terms that multiply to give me 24 and add to give me 10. So that's that diamond part that looks like an X, so I don't know why we call it, well, I know why we call it a diamond, but it goes back ways. Anyway, 10x on the bottom. So I need them to multiply to 24. If you know what those numbers are, fabulous. If you don't, you can always use this method. 1 and 24. 24 divided by 2 is 12. 24 divided by 3 is 8. 24 divided by 4 is 6. 24 is not divisible by 5, and then we're back to 4 and 6, which means we're repeating a set of factors. And the pair that adds up to 10x is 4 and 6. So 4x, 6x, put those in the boxes, rewrite that because it's a little messy and I don't want it to be confusing. 4x, 6x, and we factor out rows and columns, greatest common factor. Most we can take out of x squared and 4x is x. X times x gives us x squared. X times 6 gives us 6x. And x times 4 gives us 4x. Always want to double check. Do these two numbers multiply to give you that number? And 6 times 4 give you 24, so you're good to go. And we're to our fully factored form. Y equals x plus 2. That's our first factor from the first part. X plus 4. And x plus 6. So, advantage to being in that factored form, if you recall from 6.1 and 6.2, is we have roots. We know our roots here are whatever make each of these factors 0. So, x plus 2 equals 0, negative 2. So, often the opposites, but a lot of people have a tendency to jump ahead. And when you have factors that don't have a 1 for your a value, that can screw things up. So at negative 2, at negative 4, and at negative 6, we have our x-intercepts, our roots. We have a positive a value, because we have nothing here, which means it's positive 1. So that means our end direction is going to be up. And they're all just simple roots because none of them have exponents. So that's our graph. And that is the process of factoring a higher degree polynomial. We'll do one more example, make sure we're good to go. All right, this was one from the worksheet. We're going to have a factor here of x plus 2. We're going to put that on the side. So x plus 2. Remind you of the process that we have here. We got x to the third is our first term. And once we get those in place, then it's factor, multiply, solve, or subtract. So factor out x times x squared gives us x to the third. Multiply x squared times 2 gives us 2x squared. And I know my 2x squared terms are going to add up to be 3x squared. So 3x squared minus 2x squared gives me 1x squared. Whoops, not the color I wanted. 1x squared, or just x squared. X times x gives me 1x squared. X times 2 gives me 2x. My x term from my equation is negative 28x. These two are going to add up to that, so negative 28 minus 2 is going to give me negative 30x. Wrong color again. Factor out negative 30. Negative 30 times 2 is negative 60. And these two match, so I'm good to go. So my partially factored form is x plus 2 times x squared plus x minus 30. Scooch that up to give us some room there. Then I'm going to factor x squared plus x minus 30. And I'm going to do it the long way. If you're struggling with it, you know the short way, do the short way. X squared minus 30, multiply those two to get negative 30x squared. Middle term is x, or 1x. That's helpful for people sometimes. Factors of 30 include 1 and 30, 2 and 15, 3 and 10, not divisible by 4, 5 and 6, and then we're back to 6 and 5. Now, this one has multiplying together to give you a negative. So, if your bottom number, you need one of your factors, either the smaller or the larger, to be negative. Whatever your larger number is, if it's positive or negative, that's going to be what the sum is. So, if the sum is positive, we want our larger number to be positive. So, that means we want our smaller factor to be negative. So then you're looking at the pair of those that adds up to positive 1. That's going to be negative 5 and 6. Put those in the empty boxes. Factor out an x from that bottom row. X times x is x squared. X times 6 is 6x. X times negative 5 is negative 5x. And negative 5 times 6 gives me negative 30. So I have my fully factored form now, so this is y equals x plus 2 times x minus 5 times x plus 6. Then to find my roots, I look at what makes each of those factors equal to 0. So x plus 2, if I want to set that equal to 0, I'm going to get x equals 2. Sorry, negative 2. So one of my roots is going to be negative 2, 0. That's a point on the graph. My next root is going to be what makes x minus 5 equal 0. That's going to be a positive 5. So 5, 0. My next root, x plus 6 equals 0. So that's going to be negative 6, 0. So those are my 3 roots. So that is, in a nutshell, factoring higher degree polynomials. And I hope that helps you out. Have a good day.